It's really exciting to be here. This is my second OSCON. If any of you were here for my talk last year, this is going to be a bit different. Just by means of introduction, so as you mentioned, I'm head of data science at Qordoba. And who's Qordoba? We are a startup based out of San Francisco. We just closed our Series A funding, so we're still very small and relatively new to this space. My background is in NLP. I was previously at a different startup, also based in San Francisco, where it was kind of all NLP all the time. It's something that I really love doing. And I got into distributed computing as a result of wanting to do more and better NLP. Turns out you can do a much better job if you have a lot of computers to do it on. And specifically, the reason why this is such an interesting field for me and why I love being at Qordoba so much is because when I was younger, when I was a teenager, I decided that it was time to learn a second language, and that's what I did. And so both of my degrees are in computer science, and I've always had this love of other languages, and computational linguistics is really a great combination of two of those things. You're going to see a lot of emoji in this presentation because I gained an appreciation for emoji during my time at Casbon. And just as a super quick bio, a lot of my friends, because I've been working on NLP for a few years, they tend to think I'm just working on a universal translator, which would be really cool, but is not quite what I'm doing. You'll hear all about it today. I do a little bit more than making custom emoji in Slack. Clearly, I'm saving the world on a daily basis. No, that's not true, but we will talk about all of it. So if I could sum up Qordoba's mission, it's really what we're working towards is to enable products that feel native to everyone, regardless of what their language is. And our goal is to really make it default, that when you release a product, it gets released in more than one market at once. We want to make it so simple that everyone does it from day one. The way localization has been traditionally implemented is really human intensive, and it takes a long time. And we think that machine learning provides a much better way of doing it. So, spoiler alert, it involves a lot of open source tools. We'll go into exactly which ones those are. And we'll talk about how at Qordoba we're operationalizing and scaling our NLP models to make it fit into the broader platform, the broader application. So kind of at the heart of this talk is the concept of content really being in its own separate layer. So you can think of Qordoba as being the Docker for your content. Just like with Docker, if you can take things and put them into containers and really extract it from your core application logic, it's a lot easier to plug those in. And you can, instead of just having hard-coded English strings everywhere, if it's in a separate layer, you can have strings in lots of different languages. And not just in different languages, but different topics. So this diagram really just illustrates that bottom layer. That's your bare metal, or your sort of cloud provider layer. Above that is your container layer. That's where you're putting things in Docker. That's sort of the infrastructure for your application. That third layer is what you think of as an application today. That's your core business logic. That's everything that really provides value to your users. And then above that, completely separate, is your content layer. So that's kind of at the core of what we'll be talking about today, is really separating out the content into a different layer. And that's what Qordoba provides. So I mentioned that localization, as it's traditionally been done, it's pretty messy. It involves a lot of humans. What does that look like? It really hasn't changed much in the past 30, 35 years. And it involves a lot of different teams. There are DevOps and engineers on the implementation side, but there are also designers and product managers and linguists and marketers. There are lots of people involved in the process. And a lot of that communication is manual. We've all seen the results of this process. If anyone is familiar with the Got Milk campaign of the early 90s, it was wildly successful in the US. And the American Dairy Farmers Association, they sold a lot of milk as a result. But when they tried to scale that out to Spanish-speaking countries, the results were a little bit different because their equivalent was roughly akin to, "Are you lactating?" which you can imagine didn't help them sell a whole lot of milk. So we really think that there's a better way to be doing localization. We have so many amazing tools out there right now. And so what we've done is sort of put all that together. Now let's look at it. I want you to think about how you would localize something like this. If you were a marketer and this was the ad that you came up with, the English version is immediately effective. It evokes a particular emotion, and the problem with it is that it references something in pop culture, so something that's very specific to the region of the US that we are all a part of. Now, if you wanted to bring that into another market, if you wanted to sell that in Europe, in South America, anywhere else that maybe doesn't have as much exposure to mainstream media, to mainstream English media, how would you translate that? It might come out looking something like, it's okay if you don't know German. I realize that when this telephone service flashes, it can only mean one thing. That has much less of an impact. It's not immediately effective, and you really ruin all of the beauty of that ad. So we think there's a better way. What does that other way look like? Well, a lot of it involves automation. We're here to talk about machine learning. We're here to talk about a lot of the really effective tools that people are using to automate other applications. We're really just applying it to the localization domain. And what that involves is really from your application, utilizing an SDK, and instead of hard coding strings, you're pointing at a link that exists in the cloud. And that means that other places can access that same link, can point to that same location, and everything is consistent. So between your website, your iOS app, your Android app, everything is the same. You're only translating things once, and if you get it right in one media, it automatically is reflected in all the other ones. That also allows us to give you real-time translations. So if you're not hard coding strings anywhere, that means that once we get a better translation for you, you can automatically update it without having to redeploy your application. It means that we can provide context for your linguists. A lot of times they'll be given a spreadsheet, and it'll just have a lot of different, like each line will be a different piece of text that they're expected to translate. And if you didn't have that context of the cell phone covers, and all you had was that, I know when that hotline blings, how could you possibly translate that? So all of this helps to automate that process. My personal favorite is just the GitHub integration, because that means that as an engineer, when it comes time to deploy that code, no one's calling me, no one's asking me things. I can trust those PRs because I know that everything that's in there is just content and it's not going to bring the application down. Let's look at an example of electronic billboards. Everyone in here is familiar with digital billboards that change from day to day, hour to hour, minute to minute. This is an example from Dolores Park, which is in my neighborhood. I live in the Mission in San Francisco, and this is a pretty typical scene. Imagine that you are a produce vendor and you want to sell more watermelon. You come up with this beautiful ad that you think is going to be pretty effective, and you call up the electronic billboard company. You hand them your file and you say, I want you to deploy this in Dolores Park. I really think that people will buy more watermelon when they see this. So you do, your watermelon sales skyrocket, everyone's happy. And what do you do after that? So you've had success, how do you scale that out? Do you decide, okay, let's go across town, maybe in Chinatown. I would also like to sell more watermelon there. What do you think? Call up your billboard company, they deploy it across town, and you don't see any bump in your watermelon sales. Well, why might that be? It's a completely different audience. The type of people that sit around in Dolores Park are not the type of people that sit around in Chinatown, generally. And one thing that you can do is, okay, let's change the type of ad that we're showing. Is anyone familiar with this story of Brother Orange? It's hilarious and really long, and it's not so important. The important thing to note is that these two people are symbols of good relationships between China and America. So they might be more effective at trying to sell produce in Chinatown. So you change your ad a little bit, and you have the billboard company deploy it for you, and all of a sudden you're selling a lot more oranges. You don't really care that it's not watermelons because sales are sales, but how would you scale that out so you're happy with your watermelon sales, you're happy with your orange sales, what about that next neighborhood? You can't really go neighborhood by neighborhood across the city, across the country, across the globe. And even if you could and come up with these ads that were really effective, how would you manage that? The billboard company is not going to manage it for you. It's kind of up to you. So that's what we're trying to make easier. It's a lot more complex than people think. And we're really providing a platform that does a lot of that for you automatically using machine learning. So the core concept here is just the idea of the container. It's not just containers in terms of one language per container, but it's also domain specific. So if you're writing an obituary, you don't want your language coming from social media. If you are in the electronics field, you don't want stuff coming in from the produce world. So there are lots of different containers, not just among physical locations or languages. But the other cool thing is just that the platform is built on containers. It's in Docker running in Kubernetes, and the application itself is in containers. So it's really just containers all the way down. This is kind of the main thing that I wanted to talk about. This is the project that I've been working on. My focus is on NLP, and affect detection is one aspect of NLP that I want to go into a little bit of detail about. And it's kind of an academic term. It's okay if you're not familiar with it. It really refers to understanding the emotion that's associated with a piece of text. So it goes much deeper than just sentiment analysis. And it's important because remember that we're trying to automate a lot of these translations. We want to make that localization process as friction-free as possible. And if you know the emotion associated with two different pieces of text that are supposed to be a good approximation of each other, if those emotions don't match, then you can sort of flag it as, hey, maybe a human should look at this. Maybe this translation isn't so great. And if you have all of your emotions matching, then you can sort of fast track that through and not have to have humans look at it. But what does this have to do with open source? Well, there's a lot of open source tools that we're relying on. I really don't know how I would build something like this without using open source. It's a really critical component of how we've built our product and how we've even been able to be successful. These are a few examples. We didn't make these up. These are just these are sentences that we put into our affect detector, and we asked it for an emotion. What emotion do you think might be associated with this particular sentence? This, I had dinner with my wife. Your choices are joy, anger, fear, embarrassment, and anything like that. Does anyone have a guess what this might be? This is our machine learned model.
Seems like it could be a lot of different things.
It could. So there, one suggestion was joy. That's a great guess. What it actually gave us was something very different. And that can tell you a lot about the corpus that you're training your models off of. That's how I'll say that. We then changed one word, a single word in this sentence. We didn't even change the gender, just a single word, and we got a very different response. That was a great guess. And that is an example of, if this were a translation, that's one that you would want to, okay, those both have very different meanings, so let's just bubble that up to make sure the human looks at it. Another example, let's say you're this produce company and you're inundated with sales and so you need help. That emotion, the one that we got was sadness because you need people, you're overworked. And the translation that we came up with was busca empleo, which is something more akin to get off your lazy butt and go get a job. And that one would have a much different emotion associated with it. That's not one that would result in people in the mission applying to your job advertisement. So you would want to know about that. That's another reason, that's another time where affect detection would really help you with any sort of automated translation. This is one of my favorites. I mentioned I'm in the mission. My rent is outrageous. And one way to help with that is to put it up on vacation rental sites. So I mentioned that I learned another language as a teenager, and that language was German. So what I'm really interested in is having German people come to visit me because I want to keep my language skills fresh. I miss my time there. It's really comforting for me to spend time around Germans. So this was in my ad. This apartment is in a killer location. It has a very positive connotation in English, but to a German, diese Wohnung befindet sich an einem mörderischen Standort. Mörderisch was the translation, and that means the same thing in English as it does in German. No one is going to want to stay in a murderous location. So I would really want to know about that because that ad would not be effective in me accomplishing my goal, the sole reason why I put my apartment up. So this is what I was trying to build, and this is why I needed to build it. It needed to fit into an existing environment. So we already had an application. The Qordoba platform already existed when I was hired. And this was what I needed in order to have it fit into the rest of the landscape. It's on a microservices, it's in a microservices environment, so it just had to be a REST interface so that it could be called by anything else. It had to be scalable in terms of not just supporting every different language, but also it needs to be able to be deployed alongside everything else, and I need to be able to provide lots of different training data for it. Scalability is important. It's got to be it's got to be accurate. Otherwise, it won't be effective in stopping those bad translations from going through. And really core to our company is this support of open source. From the beginning, even before I got there, it was always a very important component, and a lot of the architectural decisions that were made before I arrived were really based on using things like MariaDB and Scala and things that were very widely supported. So with that in mind, this is what I set out to build. I mentioned Idibon before. That was this, so I was on the engineering team there, and I helped build a generic NLP platform that was this gigantic beast. It could do so many things, but I really just had those pretty narrow requirements. I didn't need this whole big, giant machine. I couldn't access it anymore. It wasn't online. So I had to take just little pieces of that, little components of it, and build something myself. And that's what I set out to do. Luckily, soon after I started, Prediction.io entered ASF incubator. It received incubator status. And what that meant is that it suddenly became feasible as a tool to be running in production that would be supported long-term, that we could really bake into our product and rely on. So it meant that I didn't have to build my own community. It meant that I didn't have to go through a lot of those growing pains, and it provided everything that we needed in terms of those requirements. I also really liked Prediction.io because it felt like being in an episode of Blue's Clues. All of the objects, so it's a framework that you use, it's classes that you pull in and inherit, and when you're writing an engine, the object is called engine. It's just like when you get mail, you talk to the thing called mailbox. It was very, very simple. The objects were clean. And that really allowed us to, instead of starting from scratch and trying to operate in step 3 at the top of that diagram, we were really able to basically overnight have something that worked, something that delivered some sort of emotion. Granted, that initial version may have given us emotions based on Simpsons quotes, but it was still something useful that we could deliver, and that was infinitely better than being in step 3 at the top of that diagram. So essentially, we started at step 3 in the bottom, at this bicycle stage. So what exactly does that bicycle look like? This is where we'll get into a bit more of the tools that we're using. Does anyone remember that scene from Apollo 13 where there's someone dying up in space, and so they lock all the rocket scientists into a room and say, you need to save this guy's life, and these are the only tools that you have to do it with? It felt a lot like that because there were just a lot of components that I had to work with. Prediction.io is on top of other things, your compute layer, your storage layer, it's all separate, you have all these options. And then there was already this landscape with all of these different open source tools. So what that looks like is essentially your compute is completely separate, and that could be a Spark cluster itself, it could be Spark running on Mesos, or it could be Kubernetes or anything running on Kubernetes. That storage layer is completely separate, so you have a lot of options. We happen to be using MariaDB and Cassandra, and I really like that choice because it kind of gives you the best of both worlds. You have your relational approach, and then you also have your NoSQL kind of in the same place because Maria lets you access Cassandra tables from natively within your data store. And then, so the affect detector is really everything that you see in the middle. It's the Prediction.io running Spark. all running on top of Docker, in Scala, running on top of Kubernetes. And so you have all of these pieces together talking to each other. Before I get too much into the technical details, I wanted to give you a really 2-minute introduction to NLP, if you're not familiar with what it is. I tried to boil it down to the bare necessities and make it as simple as possible. I think that NLP can be very intimidating to people. It can get very complex, but at its heart, it's really not that complicated. The idea is to take text and identify patterns within it. And the way you do that is we use math to identify those patterns. Well, how do you get from text to math? You turn that text into some sort of numerical representation. And in this case, we're just creating a vector of doubles. We're looking at term frequencies. That means how often a word appears, and we're assigning an index to it. It's really a fairly simple one-to-one mapping of the number of times a word appears and just turning that into a vector. And once we have that in some sort of numerical representation, that's when we perform training. And training is really just building up a model based on all of those vectors that we give it. If you think of, it's essentially just fitting coefficients to some sort of formula. If you think of your standard line equation, y equals mx plus b, you have a couple of coefficients in there. And then once you've established what those coefficients are, you can plug in any x and then receive a y. That's basically what we're doing. We're taking text, we're turning it into numbers, identifying patterns using math, and the next time we plug in a new piece of text, we can get that the corresponding result because we have a formula for it. So that process looks like the feature extraction phase. That's where we're turning it from text into a vector of doubles. And the training phase is where we're building up our mathematical models using the training data that we supply. We're applying a label to that vector of doubles. And from there, once we've built our model, and we're really just calling a library to do that. Spark's MLlib will build models for you if you just give it a bunch of vectors. And once we have that, then we can use it to make a prediction. So any new text that we haven't seen before, we can send it in, and it will tell us what it thinks it should be according to the mathematical model that we've built up. And cross-validation refers to a stage that helps us understand how accurate our models are. They're not usually very accurate the first time we build them, but cross-validation will give us a concrete number. It'll tell us your models are 40% accurate or 90% accurate. It helps us to really quantify how good our models are. And if they're not very good, that's where we would enter the stage of hyperparameter tuning. And that just means that we change a few numbers, we rebuild our models, and we go through that circle over and over again until we get predictions that are as accurate as we need them to be. That's NLP in a nutshell. We'll go into a little bit more detail, but if anyone has questions, feel free to stop me. That feature extraction phase, where we're taking text and turning it into numbers, it's really pretty simple. We talked about looking at how often a word appears. The first thing you want to do is to focus on exactly the text that you care about, and then tokenize that. So looking at the stems of words and looking at how often they appear. That's referred to as term frequency. And you could do that with single words or two words that appear next to each other or three words that appear in sequence. That's what bigrams and trigrams refer to. And you can look at a combination of those. You can look at all of the unigrams, all of the bigrams, all of the trigrams. You can make up that vector to look like anything you want. You just have to define it and use it consistently throughout your process. And the next step is the training, where we literally take all of those vectors of doubles and we assign a label to those. And that label would be some sort of arbitrary numerical representation of our emotion. So maybe 1 would correspond to joy, 2 would correspond to fear, 3 would be anger, etc. But that's literally what we send into Spark, and it spits out a model. It takes care of all of that number crunching for us. And prediction.io then just gives us this deploy command. And once you've done that, once you've finished your training, it does take a while, 10 to 15 minutes, depending on how much data you have. that's when you can do your predictions. And the prediction is really, that's the thing that we care about, and that's what we're deploying in our production product. We have a microservice that looks at that deployed model. We're building these models in advance, and then that deployed model literally just sits there and takes requests and gives predictions. This prediction phase this is the moneymaker. This is what gives us what we've been looking for. And that featureization process at the top, that's exactly the same one that we looked at before. It's always important that everything is in the same feature space. So that needs to be literally the same piece of code that gets run during both stages. But Prediction.io takes care of the rest of it for you. You've run that deploy command, and you give it a new piece of text, and it spits out an answer for you. It's actually really cool. Question?
Question, kind of a basic one. What happens if once the model is trained, then if it's confronted with a word that was not, or a token that was not in the original training set, so that maybe there's not an index assigned to it, is that not a valid input into the model, or how do you deal with that?
That's a great question. It was if it encounters a new piece of text that it hasn't seen before. Well, what Spark will do for you is it will approximate. So just like if you have a straight line and you give it a point that's sort of off of that line, it'll tell you what it thinks the closest point on that line is. So that's how it's using the models to say, okay, this is roughly what that looks like, and so I think it's this. And that's where you get different accuracies, because if it hasn't seen it before, how can your model know what the right answer is? Well, it can make a pretty good guess. Another question? Okay, we're running out of time. So, all right, so that's prediction. And cross-validation is the step we talked about where we evaluate the accuracy of our models. And we do that by splitting things up randomly into 10 different pieces. And we essentially evaluate how good it is, and we average over those 10 runs to get something that we call an F-score. And we use that F-score to evaluate how good our models are. I'm going to skip through a few of these slides because there's some stuff I want to get to that I think is more interesting. Well, this is the stack that we're using. This is mostly what existed before I arrived. This is the environment that I wanted to deploy that affect detector into. And you can see there's all of these tools are really, they were designed to do very specific things, but they work really great together. They were kind of designed to all work in concert. So this is a high-level overview of what it looks like, the application itself. We kind of talked about this before. It's a microservices architecture, so you have lots of different things that do individual tasks. And you have an orchestration layer that calls each of those individual tasks. And then you have your front end at the top. So what I was working on was just this affect detector piece. That's what we wanted to do, was take all of those machine learned models, all of those prediction models, and fit it into that architecture so that the rest of the application could just call our REST service. And this is what it looked like before. It was a Mesos cluster, and we would compile everything into jars, each of the microservices, and upload those jars, and they would all happily run along on a cluster, sharing resources, and generally one big happy family. Then the circus came to town, and that didn't quite fit into the model that already existed. So what could I do? NLP is famous for not being easy to deploy. Productionalizing NLP models is traditionally very difficult, but we didn't always have these great tools. What I ended up doing is putting everything into a Docker container. This represents my image. If I were just to do all of those steps, so everything in that diagram that we talked about, if we would do all of that in series, in a single image, this is essentially what it would look like. Everything would be internal to that container. This is something that you would really only ever run in dev. You wouldn't want to run this in production. But the problem with deploying that is that each of these stages has very different footprints. Everything in that box, those are all batch jobs. That prediction piece, that's really lightweight. It's a model that you've already built, and it just sort of sits there listening. But everything else is really pretty data intensive. The data load piece doesn't happen all the time. It's only when you have new training data. But that training phase, that's the monster. That's the really resource intensive mathematical fitting, finding coefficients. That looks very different from everything else. So what I ended up doing is in a single Docker file using the same code base, I just gave it different entry points. So I took out all of the storage layers, and I used those external storage pieces that we talked about. And that meant that we could deploy essentially from the same image, deploy containers that did each of those 3 different tasks, but we could deploy those on nodes with different physical profiles. So we could assign more CPU to the training component, more RAM to the training component. And for the prediction phase, we could sort of replicate a lot of those in just this production environment that does nothing but sit around and listen. So the batch jobs are doing other things on different machines, but it's all running off the same code base. Because remember that things like our featureization pipeline, that has to be exactly the same. We want it to be running the same code behind the scenes, but we just don't want it to be running physically on the same box. So once we did that, we were able to separate it out and put it all in a homogeneous cluster, even though it had very different profiles. And that's why we ended up choosing Kubernetes. So these are all Docker containers that are running within Kubernetes, because that gives us the flexibility to request more resources for certain containers and to bundle them together as deployments. And we could also add in all of that existing stuff. So the rest of the application. The cool thing about this is that we started out in Kubernetes just for affect detection, but it worked out so well that we ended up moving the rest of the application over into it as well, and it's performed much, much better, surprisingly. So this is what that Docker image looks like. We build everything from source. These are all the layers that we have. We just sort of add all of these components. The reason we build Spark from scratch is because there are some native linear algebra libraries that they don't provide a binary for. And I don't think Prediction.io supports Spark 2 yet. I believe that's in the pipeline. But the incubating version of Prediction.io, they don't provide a binary, so we have to build that one from scratch. But essentially, we just build up this monster image, and there's another component to it that I don't want to go into too much, but the idea is that we have a builder image, which is fundamental to almost all of our microservices, and we build each component on top of that layer so that it's all running on the same version of Java. It all has the same version of SBT. Everything else is standardized. And affect detection is a little bit different from that, but for everything else, we use this builder image approach. And the other problem that we had was just that those images were really big. Putting all of those things into a single image gives you gigantic images, especially for Prediction.io. But there's this, so we started using Docker in Docker, which worked really well in giving us tiny images, but it was there was a bit of a learning curve for anyone to actually use the thing. So thankfully, just like 2 weeks ago, they released the concept of multi-stage builds. I believe they announced it at DockerCon a couple weeks ago, but it just came out, I think, maybe 2 or 3 days ago. And that just makes it a lot easier. It's native to the Docker tool, and it means that you don't have to do these funny Docker and Docker things. You can just define it as a different build step. So that is basically, that's what we have so far. The things that we want to add to it, because this is not the end of the story. If we stuck with a bicycle, we wouldn't get very far. We want to add lots of different algorithms to it. Logistic regression is fine, but adding a lot more will give us better models because we can build different types and compare them. Especially being on Kubernetes, it's kind of trivial to do that. There's a lot of different things that we want to add, like confidence scores, to be able to understand, okay, this is joy, but it's also 10% this other thing. Emotions are especially, they're very combinatorial, and confidence scores will help us understand to what degree text associates with a single emotion. Automation will be really key in automatically pushing out the models that are the most accurate. And it might also make sense, instead of seeing this as a classification problem, also looking at it as perhaps a vector space graph problem instead. And I think one of the slides I skipped talked about how we're getting our training data. we're doing something really cool with using YouTube videos, and we're utilizing, there are a few affect detectors out there, but most of them are image-based. So what we're doing is we're taking these videos that have transcripts associated with them, and we're pulling out still images from those transcripts or from those videos and aligning that with a transcript so that now we have a piece of text and an image. And we're sending that image into these APIs that perform affect detection on images. And we're then taking the emotion and the text and using that to train our models. So we're bootstrapping off of someone else's supervised models to generate our own supervised models. And there's been a lot of new advances in that. I think YouTube or Google just came out with this video intelligence thing. I think Microsoft has a more sophisticated affect detection library, and I think IBM does as well. So the more we can adapt to all those, the more training data we can have, and the better our models will be. But ultimately, we will run out of YouTube videos to do that with. So unsupervised models is also an approach that we think is worthwhile in pursuing. And it could also be useful to generalize that instead of having very specific models for everyone or for each different container. It also makes sense to have fairly general ones, kind of like what Google does when they just sort of combine all of the data together and give you one single model. That can be useful in certain circumstances. Lighter images, we have a lot of work to do with our Docker containers, making them be faster and lighter. DockerCon, I found out a bunch of stuff to try that seems like it'll be really useful. Instead of using Ubuntu, using lighter versions of Linux, using different versions of the JDK, that kind of thing. And there's this really cool company called Weaveworks, and they provide a way to deploy things in Kubernetes automatically instead of having to write kubectl scripts. So lots of things to come. The basic, the thing that I would leave you with is just that don't kill yourself with localization. There is really a better way to do it. There are so many great tools out there, and for some reason, no one's really done much with machine learning in the space. So that's what we're doing, and it's super interesting, and it's not that difficult. It's possible to operationalize your NLP models, but it's a lot of fun. So hopefully, if anyone wants to talk about affect detection, just let me know. The next time anyone asks you, what do you want to do tonight? Affect detection. That's all I had. I don't know how much time we have for Q&A. Okay, we have a few minutes. Does anyone have any questions you didn't get a chance to ask? Go ahead.
Aren't you worried that, it was a very cool way to extract the data using YouTube videos, but aren't you worried that training the model on other models is going to get rid of the ground truth?
Yes, that is a great question. So his...
And just how are you planning on, accounting?
Yeah, the question is, if we are training models based off of other supervised models, aren't we worried about getting too far away from ground truth? That's an excellent point, because models lose accuracy. It's an approximation. It's a mathematical approximation. And the idea here is really just to build something that's scalable. So we didn't want to have to hand generate all of these models, because we support every language out there. And so this is really just an attempt to stand up something that we could scale out quickly. And part of the way we've built the product itself is we start out with these really rough models, and then as we get more data, they get better and better, because we have a feedback loop where we save literally everything. So we don't see keeping it at that stage by any means. There's a lot of different ideas we have for generating training sets. That will by no means be the only one. But we definitely see improvements by having more accurate, we see ourselves bootstrapping off of that. So it's a starting place. It's definitely not an ending place. Anyone else?
I find it really interesting. So you mentioned the use of APIs and all that. How open are the APIs? I know it's an open source product, but how accessible and how responsive is the API? For instance, if I have a string set that I wanted to translate, and how much information would I need to provide to be able to convert that string and convert convert it with a specific context in mind. So like if I have a product that was developed primarily for an English market, how much data would I need to send to you, and how long would it take to convert that set of strings to Spanish market, for example?
Mm-hmm. That's a good question. The question was, if I have a product that was targeted towards the English market, how long would it take me to send that to you and for you to convert that into a Spanish version of it? It's pretty much instantaneous. So the platform, we have models, especially for Spanish, which is a very common language. We already have models that as soon as you upload a file, that it will automatically apply those. But those have confidence scores associated with them. And so it would automatically tell you, okay, this, we think it's basically 100% accurate. These other things we're not so sure about, and you would see all of that in the interface. But we're using the models that we've already built off of other people's translations. So we're taking these generic models that aren't specific to your product, but that are specific to English, Spanish translations. And that's our starting point. And just like with your initial models may not be great, but the more customers you have that use them, the more you iterate. Because every time, let's say you get a Spanish translation that isn't correct, that's maybe pretty close, but you go in and you're like, oh, that's terrible, and so you change it. Well, we save that original suggestion, we save the fact that you thought it was wrong, and we save exactly what you changed. So now we have information about, we have positive and negative training data. And that's how our models get better over time. And specifically for you, the longer you use the product, the better those suggestions will get. But even just from day one, we've had customers for years, and so we have pretty good models, especially in high resource languages like Spanish. Go ahead.
You mentioned a little bit ago about maybe moving or potentially moving from classification model or classification towards a graph representation. And I'm intrigued, but I didn't quite follow that. Would you mind elaborating?
Yeah, so that's very much, that's something that we haven't really looked at yet. But essentially, with classification, there's a couple of ways to approach it. Multi-class classification can either be mutually exclusive or not. So you could have a sentence that is either joy or fear or anger. Or you could have a sentence that is either joy or not joy, fear or not fear, anger or not fear. So you can have an idea of how those emotions, what percentage of each emotion is associated with that. So those are two approaches. With the graph approach, you have more of a physical space. And so like you have a sentence and fear may be way over here, joy is over here, and fear is over here. So that's what I mean by graph. It's like the relationships between those rather than just a hard joy, not joy, fear, not fear.
It's a different representation.
Exactly. Just a different way of approaching the problem, a different way of representing it mathematically.
Thank you.
Mm-hmm. Okay, I think that's all we have time for. If you have any more questions, feel free to reach out to me directly. I think my contact details are up here. I always love to geek out about this kind of thing. Thank you, everyone.